Hey guys, I just wanted to go over with you how to do the building of molecular models if you're struggling, especially for my visual learners. So as you guys look here, our learning targets for this are that you can use molecular models to model what happens with ethanol burns. And so we've been talking about this process all week, and so now is your time to understand at the atomic molecular scale what's going on with all the different molecules that we've been talking about. And so just to give you guys a little introduction, so remember there's many different kinds of alcohol. Ethanol is the most common one, and that's what we saw in the investigation from this week. And it's a kind of alcohol in alcoholic drinks and biofuels. So even like you guys have talked about before in class, when you get gas and you look at the pump, it actually says contains 10% ethanol. So it's everywhere in our lives. And so what we see happens when ethanol burns is it's a good fuel source because it has stored chemical energy and it's high energy bonds. And so high energy bonds are between carbon and carbon and hydrogen atoms. And so those are ones that contain more chemical energy than others. And so when ethanol burns, it reacts with oxygen in the air to produce carbon dioxide and water. And so you guys are going to build all of these models to see how what's happening to the matter as ethanol burns. And since carbon dioxide and water only have low energy bonds, the chemical energy is released as heat and light. And we're going to be able to show that all of this happens with our molecular models during this assignment. So your part 1 directions, so it says use the models of the atoms to make ethanol. The chemical formula for ethanol is C2H5OH. So remember the C stands for carbon, and we're going to use the black atoms to represent carbon atoms. The H stands for hydrogen, so we're going to use the white atoms to represent hydrogen. And then we have oxygen, which are your blue atoms on the next slide. And so the other directions here for you guys is you're going to use the yellow lines for the high energy bonds. This is stored chemical energy. So anytime we're trying to put together, like here, where it's a carbon and a carbon together, we're going to use a yellow line to represent that it's a high energy bond. And then the other one that we're going to do is you will also see that you have black lines for bonding. And those are going to be when you have oxygen and oxygen, or oxygen and hydrogen bonded together. And again, those still have some stored chemical energy, but it's not as much as these carbon-carbon-carbon hydrogen bonds. So that's why we use the black lines to represent those. We're going to use that picture to help. And so this is what it looks like on your guys' screen, on your PowerPoint. So you're going to drag these around so that you can use them. I don't know why there's an extra one on there. So drag and drag. And what you guys are going to do is you have this picture here to help you build your model, because your model of the atoms is going to look similar to this. So for example, I'm going to move some of these hydrogen atoms out of the way. And you have enough here to build your model. So I'm going to put one carbon here, and then since it's a carbon-carbon bond, I'm going to drag one of my yellow lines over, because anytime two carbons are bonded together, that is going to be a high energy bond. And so that's sometimes hard for kids to understand, is that the matter is the atoms, and the energy is separate but stored in the bonds that hold our atoms together. And so then we need to add a hydrogen on top of this one. And so again, this is a high energy bond, so between carbon and hydrogen. And so when you guys need to, you'll just rotate these lines so that you can make them vertical and then slide them over. So you keep building until you've made this structure. And then you're going to do the same thing for our other reactant, which is oxygen. So you'll build 3 oxygen molecules on this slide. And then what you're going to do is you're going to count up all of the carbon atoms, hydrogen atoms, oxygen atoms, and high energy bonds from all of our reactants. So from ethanol and the oxygen molecules, and then you'll total them up. Then you'll answer the question on slide 10. So you'll click here and answer your question. And remember, guys, this video is for you, so you can work on something, pause it, come back to it, whatever it is you need to do. And then for part 4, we're now going to look at our products. So what you did on the slides before, like making ethanol, you're now going to do the same thing, except for now we're making the models of our products. So we're going to make water and carbon dioxide, since those are the two products made during a combustion reaction. So when we burn ethanol, we take the ethanol and oxygen, and it gets rearranged into water and carbon dioxide. And then you count up all of your atoms again, compare the parts. This is something that you guys will read about, so you'll have noticed that there were no high energy bonds in the products. Where did the energy go? Just like matter, energy cannot be created or destroyed. The energy stored in the high energy bonds of ethanol gets transformed into heat and light energy as the ethanol burns. So you'll use that information then to answer the analysis questions on 17, 18, 19. There is a duplicate slide. Gosh darn it. As well as slide 20. So if you guys run into any issues, or if something doesn't make sense, please send me an email or come see me during office hours while you work on this. But hopefully this helps you visually see how this is going to work for you guys. And let me know if you guys have any questions. Have a good day.